Okay, we're going to do a little review here today. 3.4 slopes of a line. Very, very, very simple. If you had a good algebra teacher and you took care of your business last year, you should be in good shape. Which you guys, most of you went to Midlothian High School, therefore you had a good algebra teacher. If you were so blessed to have the algebra teacher of me last year, then you're in really good shape. Just kidding. Okay, so we're going to make this short and sweet and to the point. We're not going to do every example that we could, because I feel like I don't want to beat a dead horse. Most of you guys are really good at this anyways. Alright, so key vocabulary: slope, parallel line, and perpendicular. Alright, slope, by definition, is the ratio of the vertical change to the horizontal change. Don't be afraid of that word ratio. Ratio simply means a fraction. It's the fraction that compares the vertical change, the rise, to the horizontal change. If you guys remember the rise or the run, you guys that were in my class last year, maybe you remembered the slope song. You know, I'm not going to sing that for you, but if you ask Trevor Sorrells, he might actually do that for you. He loves it. Favorite song, iTunes hit. Okay. If you were in my class last year, and I don't know about the other algebra teachers, but I did teach the delta y over delta x. Delta is the Greek symbol that stands basically for change or change in. So this means change in y over the change in x. It's just another way to write the definition here. Okay. The slope formula, of course, is y2 minus y1. That's how you get that change. And then x2 minus x1 over x2 minus x1, or divided by x2 minus x1. That equals the slope. In this case, if I subtract the two y's, I'm going to get a 6. Okay, and if I subtract the two x's, I'm going to get a 3. I put the 6 over 3, and I end up with 2. Okay. So let's talk about that. What's got the greater slope, or the steeper slope? So the greater the number you have, the steeper the slope. So which one's steeper here? 2 or 3/2? Well, 2 is 2, and 3/2 is 1 and 1/2. So the steeper one would be 2. So the greater the number, or the greater the slope, the steeper the slope. So this number is bigger than this one, therefore 2 is your steeper slope.
Ladies and gentlemen, I hope it's...
Okay. So that's pretty self-explanatory. Another thing we want to look at here is when we analyze slope, we read slopes from left to right, just like you're reading a book. Okay, you read from left to right. From left to right, if the slope is going in the upward direction, then you have a positive slope. If it's going in the downward direction, you have a negative slope. If the line is horizontal, okay, then you have a 0 slope. And if the line is vertical, then you have an undefined slope. Some of you guys may have seen this little creature on the board in the classroom. This is what we call slope dude. This just kind of gives you a brief, quick memory tool. His eyebrow going up is positive, eyebrow going down is negative. Straight up and down, that's the undefined slope. And then, of course, your horizontal line, that's your 0 slope. Just, again, review. You should know that pretty well. Again, a lot of you, I think, you could understand and analyze positive, negative, 0, and undefined slopes. All right, so if I'm given two points, or two ordered pairs, or two coordinates, however you want to look at it, I need to find the slope using the slope formula. I use the slope formula by simply plugging it in. Now, Miss Wilson last year, when she reviewed this with her students, one of the things she said is just go ahead and connect the y's. And I thought that was kind of an interesting concept. She said just go ahead and connect the y's and connect the x's. One of the things I taught my students last year was to label the x's and y's. So this would be x1, this would be y1, this would be x2, this would be y2. That way when you plug it into your equation, then you have it in the right order. Now here's the deal. Let me take this over here for just a second. Okay? Before you plug it in, one of the things that's so important to remember, and again, I know I'm talking to the best algebra students here, one of the most important things to remember is that those negative signs are part of that formula. So it has nothing to do with the signs of these numbers. That negative sign just comes with the formula. So when I put this in here, I'm going to take the 4 and put over here, and 4 minus 0, because that is, okay, y1 minus y2. Now again, if you're like me and you're a traditionalist, okay, well, I thought it was y2 minus y1, then I could do 0 minus 4. So let's do that first. So here's 0 minus 4. and then x2, 4, minus x1, 6. Oh. Okay. Well, 0 minus 4 gives you negative 4 over negative 2. Negative 4 over negative 2 is positive 2, right? Negative divided by negative is a positive 2. Now let's take this over here again, and let's try this again. Because earlier I started with doing 4 minus 0. Can I do x1 minus x2? I'm sorry, y1 minus y2 and x1 minus x2? Can I do that in that order as well? Well, let's test it out and see. So here's y1, 4, minus y2, 0. x1, 6, minus x2, 4. So x1 minus x2, 4. If I do the calculations here, I have 4 minus 0 is 4. 6 minus 4 is 2. 4 divided by 2 is still 2. Okay? It doesn't matter. They just tell you to do it. Make sure you group it appropriately. So do all your x1s first, or do all your 1s first, or do all your 2s first. As long as they're in the same order, it doesn't matter. You can't do this. I can't put 0. I can't put 0 minus 4, because that would be y2 minus y1, and then do 6 minus 4. Because that would be y2 minus y1 over x1 minus x2. You can't put them out of order, so I've got to put the 6 over here. So order is important there. Okay? Another review from last year, you should have learned that parallel lines have the same slope. If they have the same slope, that means their magnitude or their angle that their direction they're going is going to be the same. If they both have the same angle, they're never going to cross one another. Okay? So parallel lines have the same slope. So if something has a slope of 2 and another line has a slope of 2 over 1, they're both the same because 2 over 1 will reduce down to 2. So 2 is 2. Okay? If you have perpendicular lines, they intersect to form right angles, and they have negative reciprocal slopes. Okay? What does that mean? Well, here's my perpendicular lines. That means they create a right angle, right? These two lines intersect to create a right angle. But negative reciprocal slopes means this. If I'm given the 2/3 slopes, my negative reciprocal would be, I would put a negative sign here now and flip it. My reciprocal is simply flipping the numerator and the denominator. Okay? If this was already a negative to a negative would make this a positive. So if I switch these, okay, if I come in here and I put a negative out in front of that, now my negative reciprocal, negative would be a positive, and that's what happens there. Okay? Pretty simple. Make sure if you have any questions, you write them down so we can talk about it in class tomorrow or in tutoring. Okay? Please, 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 I can't stress that enough. Make sure you always write down any questions you have and bring them to me the next day. Okay, let's go ahead and talk about linear equations. Several different types of linear equations. We have our slope-intercept form, which is the y equals mx plus b. Okay, if I'm given a slope m equals 4 and a y-intercept of b, then my slope-intercept form would simply be y equals 4x plus 1. Very simple. I don't think we need to spend a lot of time on that. Then you have point-slope form, which I find to be basically obsolete. You don't need to use it a whole lot, but basically you use point-slope when you're given a slope and you're given a point, and you simply plug that in. So here is my y1 value, which I take this y value and I plug it in here. And then I take my m value, my slope value, plug it in here before the parentheses, and then I take my x value, x1, and plug it in here. Notice the negatives go with the equation, and so these two negatives would end up becoming positive later. And then, of course, from the point-slope form, a lot of times what you'd end up doing is solving for y and putting it in slope-intercept form anyways, because you really don't use point-slope form for anything particular. And you can use a point and a slope in slope-intercept form the same way. If your Algebra 1 teacher didn't teach you that last year or didn't show you that last year, feel free to just stop by and ask me how do I never use point slope form. Okay? Because again, I taught my Algebra 2 students this last year and they were like, well, I wish I was taught that before because point slope is just a hassle. Okay? Because point slope also you don't have to deal with distribution or solving for y as much. Okay? So what do I do if I'm given 2 points? Now that I know I have slope-intercept form, I have point-slope form, what do I do if I'm given 2 points? Well, the first thing I need to do is I need to use my slope formula. Okay, so my slope formula, I would plug this in. I have y2 is 2 minus, which is part of the formula, y1, which is 6, then x2, which is 3, minus -1. Okay, that's not part of the formula now. And I end up reducing, I get 2 minus 3 is negative 4 over 3 plus 1 is positive 4, so I have negative 4 over 4 is negative 1. So how do I write the equation for that now? Well, now I have a slope and I have a point, so I can use point slope. And again, or you could use a slope-intercept form in a different manner, which I could show you in tutoring if that's something you'd be interested in. Because again, we don't usually leave stuff when you get to Algebra 2, and hopefully they taught you in Algebra 1, you don't really leave stuff in point slope form. And last but not least, we have the point equation form. And basically that's giving me a point and it's giving me an equation. And then this right here might be something new that you haven't seen from Algebra 1. This is a point. And it says basically here, given the point 2, 0, I need a perpendicular line that is perpendicular to the equation y equals negative 2/3 x plus 1. Okay, so how do we do this? Well, it's pretty simple. I'm going to use my point slope formula. Okay, and again, you don't have to, but you can use the point slope formula. I have y minus 0, which is your y1 value, equals. Notice what I did to my slope here. If it's perpendicular, I flipped it, made it 3 over 2. Because it was negative, I changed it to positive. I changed the sign. And then I have my x minus x1 value. My x1 value is that 4 there. I'm sorry, that 2 there. Okay. And again, the reason I went ahead and just kept this note the way it was versus changing it the way I teach it is because most of you were taught, or everybody was taught point slope formula, and not everybody was taught how to plug it into the slope-intercept form of a line and do it that way. Either way is fine. Whatever works for you is great. So, again, if you have any questions, this is all pretty much review, so I didn't want to beat this too badly, and I know I went quickly through this, but I feel like most of you probably don't need to watch this video in order to be successful on this unit or this section. If you have any questions, write them down. Come see me. All right, have a good night.